This is TWIS, This Week in Science, episode number 945, recorded on Wednesday, September 27th, 2023. Don't be afraid to ask stupid questions. Hey everyone, I'm Dr. Kiki, and tonight on the show, we will fill your heads with scams, weed, and worms. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. Science is an ever-evolving journey of learning new things. Where we are today, the knowledge we have gained could not have been predicted 50 years ago. Where we go next, the knowledge yet to be discovered, cannot be predicted today. At least not specifically. But generally speaking, we know exactly where we're headed. Towards a future of knowing everything. How things work, how they interact with other things, and how to enhance or suppress the way those things operate. It may be difficult to imagine at times the things we have yet to learn. We don't even have names for them yet. But in time, as the unknown things are discovered, the unknown things will be named. And then we will know what to call them. In the meantime, we will keep an eye out for new things here on This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you, Kiki.
And a good science to you too, Justin. And welcome to everyone to a new episode of This Week in Science. We are back again. Oh, yeah, to talk about the science. We always love to talk about the science as opposed to all the other things that might, be keeping us down. I don't know. Anyway, we like to lift people up with science, optimism.
Yeah, I have no idea what could
thoughts.
be bringing anybody down because I now live in Denmark.
That's right, you
the
live in Denmark.
Happiest place on earth. We don't have problems here.
Oh,
it's
no.
really interesting. It's a really strange thing.
You're like,
to
I
leave
think
a
I'm
country
going to have a problem, and somebody comes
with
around.
Problems and controversies, and come to a country where everything's
No problems.
Fine.
It's all
No
good.
problems.
All right. Well, we're going to have a great show. We really are. I'm just letting you know right now. But as we stream this broadcast, tomorrow will be Ask a Stupid Question Day. So in honor of the day, I invite you to send us your stupid questions this week, and we will answer them in future programs.
Well, we actually already got one in the chat. Iron Laura says, how does Justin not have any gray yet? Oh, man. I do. The trick is, I never dye my hair. I'm never going to do that. The trick is to get your hair wet before airtime. And then you can't see it. But this is all gray all through here on both sides. So thank you for talking about my youthful appearance. But it's all a ruse.
Well, at least they're asking about your youthful appearance instead of mine. So that's good. I'm happy. Yeah, what do we have on the show tonight? I brought stories related to the physicality of cells, some space news. I've got some IgNobels, which we love so much, and also some brainy stuff for the end of the show. What did you bring, Justin?
I've got a public service announcement about scams. Engineering feat has converted salt water into fresh water without electricity.
Ooh.
I got some really old wood, oldest wood ever.
Okay.
And a potentially controversial story about weed.
Potentially controversial.
About
Well,
the
we're not going to
marijuana.
bias anyone right off the bat. There we go.
Yeah.
Yeah.
It's potentially, it's a
Well-
story I was doing for Medical Express that took a turn I wasn't expecting. And I'm the one writing it. And I didn't know I had this opinion. And apparently I did. So we'll get into that at the very end of the show.
Cannot wait. If there's nothing better, it is discovering new opinions.
Yeah.
Here on This Week in Science. Okay, if you want to subscribe to us, you can find us on YouTube, Twitch, and Facebook, where we broadcast weekly, 8 p.m.-ish, for our live podcast broadcast. That is then turned into a real podcast, and you can find us as a podcast on just about every place podcasts are found. Look for This Week in Science. Our website is twist.org. You can find us as Twist Science a lot of places. Are we ready for the science?
Let's do it.
Okay, let's start off with some fun. Wheel of Science fun. Woohoo! Every year, the IgNobel prizes are given out prior to the Nobel prizes. This year, they were handed out on Thursday, September 14th at the 33rd first annual Ig Nobel Prize ceremony. And dun, 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 this was a webcast. They're going to be doing a live in-person version later in November. But for right now, we know that the prizes, first, in chemistry and geology, are to Polish and UK scientists, Jan Zalesiewicz, for explaining why many scientists like to lick rocks. Why do scientists like to lick rocks? Well, you'll have to find out in the paper Eating Fossils, published in the Paleontological Association newsletter number 96 from November 2017.
So, it sounds to me like this is an old geologist methodology.
Indeed.
That probably at some point they realized it's not as accurate. Or
no, actually, you got to talk. You really do need to dig into this one because it is a very tried and true methodology. Certain rocks, you can lick. Certain rocks, you can't lick. Certain rocks, if you're in the field and you lick them, they help you determine what family of rocks they're actually in and what compounds are in them. So the chemistry is involved. So there's a lot of interesting aspects to why geologists lick rocks. It's true. Seriously, rabbit hole this one. It is great.
No.
Literature
just picture
prize.
that class. Can you picture the classroom when everybody walks in? Everybody's like, "Oh, hey,
Here are your
everybody's got a
rocks.
rock on their desk today."
Lick
Interesting.
the rocks.
Okay.
Yes.
Well, today what we're going to be doing is taking notes. We're going to lick rocks and take notes on what you notice. Gosh.
Literature prize goes to France, UK, Malaysia, and Finland for studying the sensations people feel when they repeat a single word, many, 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 many times. The paper is the induction of jamais vu in the laboratory, word alienation, and semantic satiation. Yes. The jamais vu, never seen, or the before, the sense of having seen it before, or no, yeah, it's like, it goes away. Mechanical Engineering Prize, India, China, Malaysia, and USA for their research in reanimating dead spiders to use as mechanical gripping tools.
Oh, yeah, we covered that one.
Yes, we covered this story. This is the one in which they were using spiders with kind of hydraulic forces to use them for new arcade games.
Yeah, basically, they pump into the spider, and the legs would grab onto something, and then they could release the fluids, and they would. Yeah, that's going to come in handy someday.
Yeah, this paper, Necrobotics, Biotic Materials as Ready-to-Use Actuators.
Oh, necrobotics, this sounds so terrible.
Necrobotics, it's my favorite. Seriously, it's my new favorite future science. Okay, Public Health Prize goes to South Korea and the USA for inventing the Stanford toilet. This is a device that uses a variety of technologies, including a urinalysis dipstick test strip, a computer vision system for defecation analysis, an anal print sensor paired with an identification camera, and a
what?
telecommunications link to quickly
what?
monitor and analyze the substances that humans excrete. Yes. Yes. You heard me right. You heard me correctly.
So
we reported on this toilet a while back, and
I remember that. I remember the
Yeah.
monitoring part. I forgot completely about the
how it
identifies
Yes.
who
Yes.
it scans that. So it's kind of like like an ear is very individualized, the iris of an eye, the fingerprints are very individualized. So too, I suppose, would be the part you're aiming down at the toilet. Well,
indeed.
Hey, you know what? We could really actually use that technology in other fields. That could be, talk about high security. Hey, I'm the only one that can open this vault because it requires a scanning.
Oh, how were you able to get into that vault? Well, on Valentine's Day, someone gave me a chocolate. Anyway, serious.
I don't know what you mean by that, and I don't
hope,
want the answer.
I hope nobody gets that joke.
I don't want the answer.
Communication prize, Argentina, Spain, Colombia, Chile, China, USA, is for studying the mental activities of people who are expert at speaking backward.
Oh.
Paper. Neurocognitive signatures of phonemic sequencing in expert backward speakers.
Expert backward speakers. Yeah, that would cause my brain to completely derail to try to.
How do you become an expert backward speaker? When do you use that?
How does it occur to one to even begin training?
That
skill.
Yeah.
Well, there's at some point when I remember, like as a kid, trying to do the alphabet backwards.
I mean, Pig Latin, the alphabet, but
it didn't keep trying to do that.
No, but I guess there are probably expert Pig Latin speakers.
Yeah.
As well, medicine prize, USA, Canada, Macedonia, Iran, Vietnam, for using cadavers to explore whether there's an equal number of hairs in each of a person's two nostrils.
There could not be.
Quantification and measurement of nasal hairs in a cadaveric population. According to their abstract, there's no abstract available. Come on. Gotta give me an abstract here. Nope, no abstract available. That's too bad. I would like to know.
It's one of those studies, though, too. It's like you're quantifying a thing. You can quantify anything. It's like, well, we're going to compare the number of hairs on a mule to the number of hairs on a hare. Like, okay. I guess there would be limited benefit in knowing the symmetry of nasal hair.
Yeah. I don't know why. I honestly am curious as to why that would be a question you would go about quantifying. In nutrition, Japanese researchers took home the prize for their experiments to determine how electrified chopsticks and drinking straws can change the taste of food.
Electrified straw? So... Ow! Ow!
Electrified chopsticks, every bite.
Ow! How did that change the taste of your food? I don't like it.
I don't know. Augmented gustation using electricity. They're conveying information humans cannot perceive with their tongue. I don't know whether it worked or not, but that was their new methodology. So anyway, in the education prize this year, Hong Kong, China, Canada, UK, the Netherlands, Ireland, USA, Japan, very cross-cultural here, got the prize for methodically studying the boredom of teachers and students. And their title of their paper is Boredom Begets Boredom, an experience sampling study on the impact of teacher boredom on student boredom and motivation. If your teacher is bored when they're making the lecture, it's a pretty good chance the students are going to be bored as well.
That sounds completely reasonable.
I think it's very reasonable.
Yeah.
Like, that really makes sense. And then we have two more. The Psychology Prize goes to Stanley Milgram, Leonard Bickman, and Lawrence Berkowitz for their work back in the late 1960s for experiments on a city street to see how many passersby stop to look up when they see strangers looking up.
Okay. Out of all of these ignobles, like sometimes you can go, oh, you do an experiment just to practice doing a kind of an experiment. You just didn't have anything. You're going to count nose hairs, see if you can do it, see how you quantify it. See it.
It's a new measurement.
This one is just fun. This one is just giggles.
Yeah, they found that as the size of the stimulus crowd was increased, a greater proportion of passersby adopted the behavior of the crowd. So the more people are looking up, the more people you're going to get looking up. The final prize
you can't resist it. You see 3 or 4 people looking up into the sky, you're going to be like, oh, where? And then, of course, you don't see it right away. So you keep looking, scanning, trying to figure out what's up there that they're looking at, because sometimes things are hard to see. Oh, that's hilarious. I love that one.
Finally, in physics, Spain, Galicia, Switzerland, France, and the UK are awarded this prize for measuring the extent to which ocean water mixing is affected by the sexual activity of anchovies.
Huh.
Basically, their title of their paper says it: intense upper ocean mixing due to large aggregations of spawning fish.
Yeah.
The anchovies, they go crazy. It mixes the water. It's a whole thing. It's like a force of nature or something. Eh? And that's it for the Ig Nobel Prizes for 2023. Congratulations on the new inductees into the Hall of Ig Nobel honor. And we will be looking forward in the next few weeks to the Nobel Prizes as they are announced, as they usually are. During
but those are all going to be for boring stuff.
Like real
science,
whatever.
Here's the thing we expected to find, and we found it, and it's in a field that everybody else is studying. And,
I know.
So that's always also exciting to see who they've given it to.
Yeah, we're super excited. Yeah. So we'll be looking forward to that. But let's get into the new recent science. What has happened this week? You have a warning for us. Yes, Justin?
Yeah, so this is something I wrote up for Medical Express. It was a short kind of study, 644 older adults, and by older adults, 85.6 was the average age. They were part of the Rush Memory and Aging Project, MAP, an ongoing cohort study looking at conditions related to aging. What they decided to do was they tried to trick their participants with a mimicking an information scam, or a scam where somebody pretends to be calling from the government and needing information from them. Of the 644 participants, the majority, 68.5%, 441 of them, did not engage at all. So they got a variety. Some got emails, and some got things in the mail with a phone number they needed to call. Others got a direct call from the scam. 68.5% hung up or never called to engage.
That's great. Congratulations. Yes. You win by not engaging.
You did it. You did. 97 or 15% of them engaged skeptically. I like these folks. These are probably the more savvy ones. They're like, hey, you sound like you're scamming me, and want to tell them about it. Then sadly, 106 or 16.4% of the cohort were part of the conversion group. Those converted, nearly 3/4 provided personal information to the scam.
No.
Yeah. So
how is this different from other age groups, though? That's what I mean.
Well,
we're focusing on these older adults, but is this just normal, or is this like a particular problem? I mean,
and they don't they don't have the normal group. I know that these scams do hit people of all ages,
Yeah.
but we are. It's much more common to hear about it happening to the elderly.
Yeah.
So they looked at why these different groups of people or different people had sort of fallen for, not engaged in all, or had sort of been skeptical about it. Those in the skeptical engagement group, turns out, had the highest cognitive scores and the most financial literacy. But the thing that was sort of overriding in the group that gave up personal information was that they had the lowest scam awareness, meaning they were just less likely to have heard of scams.
And they just aren't thinking that way.
So they're just trusting.
Yeah.
Because why would anybody pretend to be the IRS or the DMV or the whoever's calling?
Yeah.
Why would anybody even do that? What would be the point of even having my personal information? They're not me. They can't do anything with it, right? Yeah. So this is according to the National Consumer Law Center, nonprofit organization. There are 30 million robocalls from scammers daily in the United States. And the results are about $30 billion in theft each year. It is estimated that 70% of Americans do not even answer the phone if it's an unknown number, due to having received so many robocalls in the past. And the problem is the do not call list that was established. I think everybody's on it now. Problem is it only works with legitimate businesses. The do not call list does not work with scammers. Now, a lot of the telecom companies have developed, you've probably all seen it, the scam likely that will appear on the phone to let you know that that call that's incoming is likely a scam. So that's huge. That's a huge step. But there's also spam emails that can go out that claim that you have made verifying that you've made this purchase of some amount from maybe a company that an Amazon or something like this that you do have transactions with, and you go, oh gosh, I didn't make that purchase. I better respond to this. Or you get a text from the bank.
Don't click on anything.
A text from the bank saying, oh, hey, there's a problem with the account, right?
Don't click on anything.
Yeah.
Just delete it and then call the source. Call your bank. Go to your account on Amazon directly. Do not click. This is my public service announcement. Okay.
Right. So this is the public service announcement, because it turns out that just knowing about these scams is the thing that prevents people from falling from the scams.
Yeah. Okay.
So things to know: Amazon, Google, Microsoft, IRS, computer support from Best Buy, Geek Squad, credit card companies. Do not call consumers and do not transact any business through email. They've spent billions of dollars creating their transaction platforms. They do not call. They do not email. This is not how they communicate with you any longer. They do no business this way. And they never transact any business through gift cards.
No.
Anybody asking you to buy a gift card is a scammer. And the reason they use gift cards is because it's untraceable. You can get a number over the phone, redeem it on a computer halfway around the world. And there you go. The other common scams that are of note are low-cost vacations, where we just we're doing a promotion where we want, for $600, you can have 4 nights at a hotel and wherever you want. That's a scam. Extended warranties. You get calls for extended warranty. They want to, it's an extended warranty company. You're putting a warranty on your car. That's a scam. There is student loan forgiveness, apparently, has been a scam.
That one's rough.
So you also look for whatever's in the news. PPP loans, student loan forgiveness. Additional benefits through Social Security, anything like this over the phone. All of this is going to be a scam. Additional insurance for the elderly over the phone, also a scam. Debt collection can be a scam. You also have to watch out for if you're looking for a job, because there's fake job postings that exist, which is why if you see a company that has a job posting on one of the posting sites, whatever they may be,
go to their website.
Go direct to the company and look for it.
Yeah.
For that, because you don't want to give your information to just anybody over the phone. So anyway, if police charities do this too, there's all sorts of charities, we'll call it. Go to a dedicated website for the company if you're really that interested, but do not respond to any community. Trust no one except for me right now, telling you not to trust anybody. Trust me right now. And then after this, don't even trust me.
No, continue to trust us. I hope we're a trusted source. We're helping you.
My favorite one, though,
I don't want your personal information. I don't want it. I really don't want it.
My favorite scam is, I've gotten this call a couple times. I've gotten it from both FBI and from the DEA.
Oh, no.
Where an agent calls about a car full of drugs seized at the border, and it's connected with my information somehow. And so they're going to be sending the police to my house unless I can figure out, and I can start a case, but the only way to start a case is to agree to send $500 via gift card. Again, because that's the only way they can get money. No, it's not the only way. You also, here's another very important one before we move on. Never allow any form of remote access. If somebody is on the phone asking you to download an app onto your computer, do not do it. It is, a scam where they're saying they're going to be refunding you money that you obviously didn't pay. It doesn't exist. There is no automatic Geek Squad charge from your Microsoft account computer. There is no Amazon MacBooks that are being purchased halfway across the country. It doesn't exist. What they're going to do is get in and manipulate it so that it looks like they have accidentally refunded you too much money, and then you need to send them gift cards.
Mm-hmm.
It's always
more gift cards. More gift cards. Or log into your bank account and transfer money directly.
Yeah, so they can do that. The only problem is that gets flagged for any significant amount of money. So what happens then is you get a text alert from you on your phone, a third-party verification with a code. And the scammer will ask you for that code because they know they're getting prompted on your computer because they've taken over and they're hiding it from you. They're getting, what is the code to complete the transaction? And so they say, just so that we can make sure this money makes it to your account, can you verify the number on your phone? Bank accounts, life savings have been drained this way.
Absolutely. Yep.
So don't fall for scams, and tell people, tell the elderly, tell the naive, tell the savvy, tell everybody.
Keep repeating it.
Yeah.
Yeah.
Keep
repeating it. Repeat and repeat, just over and over again, because let's help the people.
Yeah.
Who don't know enough to help themselves. Help them out.
And the best way that we can get the word out is for everyone listening to go out right now, get a gift card for $499
and mail it to oh my goodness. All right. Well, let's move on from gift cards into the real gifts of the universe. Space news. Dun, 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 dun. From NASA this week, 2 stories. Dun, 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 dun. First story is, yay! OSIRIS-REx, the mission to the asteroid Bennu, successfully returned a sample to Earth this last weekend. The deserts of Utah were graced with a canister dangling from a parachute as it floated at many thousands of miles an hour towards the surface of the Earth and needed to be slowed down. Anyway, this canister was then taken very carefully after it crashed in the desert, very carefully to Johnson Space Center in Houston. And since then, it's very exciting. They just today, or in the last 24 hours, have opened the canister lid for this sample. They have a laboratory setup that is a clean box that this sample is within. So everything is being done in a way to make sure there is no contamination by people of this sample since it has returned from space. They opened it up and they saw that there's a bunch of dirty looking dust on top of the stuff inside. They don't know what it is yet, but there's more work to be done in the preparation of this sample for its next steps in early October when it will begin to be analyzed. And there is apparently going to be a live stream on October 11th at 11 a.m. Eastern Time. They're going to work together to complete the disassembly process and reveal the sample to the world. So we can all see this sample of a chunk of rock and ice that was brought back from asteroid Bennu over. Nice. This is a wonderful mission. Like, this is similar to the Hayabusa missions. This is the strategy and tactics involved to make this happen are many, many years in the making. And so this is a very exciting opportunity for us to figure out what this class of asteroids is made of, how it evolved, all sorts of stuff, letting us know about our solar system.
Yeah, this is also the one that is projected to potentially hit the Earth in like 160 years.
Yes, in a while. Not right away, but in a while. Yeah.
And and if that happens, it will most likely fall into the water. But if it doesn't,
it's a big one. So
it's a big one. It's not one of those like civilization enders, but it could take out a large farm in the Midwest. Or a bunch of farms in the Midwest. Like it could do enough damage that it would be like really something if it hit where people were. The thing is that there's mostly water on the planet. However, the idea of deflecting it is going to come down to what this is made of. Because what was it?
Exactly.
It was Itokawa. Actually, the Hayabusa mission, Itokawa, the asteroid, turned out to be like mostly gravel.
Yeah, very.
Which means if you went and did a thing to try to push it, it would maybe just sort of like
break apart,
poof up out a little bit. It's not gonna get moved off of course because it's structurally not one solid object. So knowing whether or not this one's a solid object or not, we'll let the folks 160-ish years from now be able to decide whether they want to try to deflect it or just let it go.
Just let it go. Well, for now, the craft that returned this sample is still on its way further into space, off to look at another asteroid, Apophis. So it is heading out to look at more things. It's not done yet.
Wait.
Yes.
It can do that?
Yes. It just dropped off the sample and kept going. The craft is like, see you later. Got another asteroid to meet up with. Hey, just dropping this by. Hope you like, just then I drop it on your doorstep.
That's some next level NASA. It's just staying out. Cruising around. That's wild.
It's amazing. I love it. Yeah, this is wonderful. And speaking of things smashing into each other, NASA has also been working with the Durham University location of the Distributed Research Using Advanced Computing, DIRAC, supercomputing facility in the United Kingdom. And they've been trying to figure out where Saturn's icy rings came from. So the Cassini mission gave us a really up close view of the rings and let us know, hey, these rings are basically only made of ice. So where would all this ice have come from? How could it have come about? And researchers have a few hypotheses about how that could occur. But in this situation, they created a simulation for the impact of two primordial moons of Saturn that probably got knocked out of whack by the sun itself. So the moons are orbiting around Saturn, being held in check by Saturn's gravity itself, but they're also being impacted by the orbit around the sun. And so it's possible, they think, that these icy moons were knocked out of their orbits just enough so that they ran into each other. And these icy moons crashed, and according to simulations, gravitational forces from Saturn would have kept all that ice right around Saturn and would have led to the formation of these moons. So the formation of Saturn's rings is thought to have occurred only a few 100,000 years ago. Not 1,000, excuse me, 100 million years ago. So possibly during the time of dinosaurs, this was occurring. But then the question that this leads to is, how dynamic is the ring system of Saturn, right? So we're looking at it from a fairly stable perspective, right? Just looking at the skies for
Snapshot.
and being able to see the rings of Saturn for a very limited period of time. And this is, millions of years, but at the same time, for icy moons like Enceladus, where we think there might be liquid oceans under which there could be life contained in the methane liquids under an icy crust, is it possible that life could be coming about if that Jovian, the Saturnian moon system is so dynamic? Is it possible that these moons are young? Is it possible that life has occurred and then it's smashed to bits? Is it possible that it may yet, in one of these more stable moons that we think of as more stable, be smashed to bits? I don't know. What does it mean, everybody? And if we're looking at it on the, hundreds of thousands, millions of years, hundreds of millions of years, what time frames are adequate?
Very good question.
Right?
So I've come to the opinion somewhere recently that life exists pretty much everywhere in the galaxy, and therefore probably the universe. Anywhere there's an Earth-like planet, certainly. Now, maybe even moving that into some non-Earth-like planets. If we do find any signs of life on Enceladus or one of these icy moon things, if we find a good signal of life, that opens it up even more.
Yeah.
Because it's going to come down to chemistry and physics for the basic building blocks.
And then time, right? And
time.
What forces are there? You've got the chemistry, you've got the building blocks, right? Do you have the right temperatures? Do you have the right acidity? Do you have the right amount of time?
And there's a certain amount of that's when you say the right, we're not just talking about what Earth is today. We're talking about actually a really wide span. Exactly. What is it? 10% of the biomass of the Earth or something like this is living below meters, 10 to 20 meters below the soil surface all around the planet. Yeah. So what we expect as an animal on a planet, life to look like, isn't the only way that life looks. And it's not the only condition that life can exist.
Yeah.
It's just the only one that's interesting.
But I think it's an interesting question brought up, and it's we look at things from our human-centric perspective, where it's just this is what it is. But there are so many millions of years of dynamics moving on around us, and I love that we can use these supercomputers now to be able to come up with these simulations that give us an idea of various possibilities and support or refute various hypotheses we might have. Yeah. It's just physics, man. Anyway.
That's all it is.
Yeah. Tell me about chemistry, though, and engineering. There's something important there.
So there's a thing that we talk about every once in a while. I don't know why it's an ongoing thing because the world is running out of fresh water is why it's an ongoing thing.
That would be
Turning
why.
salt water, which again 3/4 of the planet, even more maybe, is covered in. Engineers at MIT and researchers in China are turning seawater into fresh drinking water with a completely passive off-grid device inspired by the ocean and powered by the sun. So the configuration of this device allows water to circulate in swirling eddies in a manner similar to the thermohaline circulation of the ocean. Circulation combined with the sun's heat drives water to evaporate, leaving salt behind. The resulting water vapor can then, of course, be condensed, turned into drinkable, pure, fresh water. And through some trial and error, they've managed to design it so that the leftover salt continues to circulate through and out of the device rather than accumulating and clogging or being filtered.
Oh, that's one of the things I wanted to ask about, because I think this is huge for desalination, for all sorts of, what happens to the salts? Do we have membranes to clean? What's going on?
So from what it can look like, they did something kind of clever. So let me see if I get it. So the initial design, which the team tested on the roof of the MIT building, efficiently converted the sun's energy into evaporated water, which was condensed into drinkable water. Success. But the salt that was left over clogged everything up. Mm-hmm. So that, you could run it for a while, but the leftover salt settling and accumulating on the device made it so that it was didn't last too long. You'd have to replace the whole thing.
It gets full of crud.
Too expensive. Mm-hmm. Keep replacing this configuration. So then they, in follow-up effort, they devised a solution with an added feature that helped circulate incoming water as well as any leftover salt. And this design prevented salt from settling and accumulating in the device. And it desalinated the water, though, at a relatively low rate. So it slowed down the system so it wasn't as efficient at creating fresh water. In the latest iteration,
you still have, it's expensive for a different reason.
Yeah, it just takes too long. Mm-hmm. The team landed on a design that has achieved both a high water production rate and high salt rejection, so that the system can quickly and reliably produce drinking water for an extended period. And the key, according to this, is that new design is a combination of the previous concepts, multi-stage system of evaporators and condensers that is configured to boost circulation of water and salt within each stage. So part of what they're taking advantage of is having the salty water keep moving through the system below the surface. And that generates something similar to the thermohaline, the temperature and salinity differences, which seems to actually be accelerating some of the evaporation maybe, and keeping the salt from settling and clogging, and then later it can be expelled.
One of the big problems with desal systems is that they are usually very electricity intensive. So it's like the energy water nexus, right? So the more fresh water you want, the more electricity you need to desalinate.
Yeah. So this is completely off-grid, passive, no electricity added.
That's incredible.
Okay. It's a big box and it's tilted a little bit. I think they're taking advantage of gravity, moving things down the different stages or compartments of this. From the test, the researchers calculated that if each stage were scaled up to a square meter, it would produce 5 liters of drinking water per hour. And that the system would desalinate water without accumulating salt for several years. Given the extended lifetime, the fact that the system is entirely passive, requiring no electricity to run, the team estimates that the overall cost of running the system would be cheaper than what it costs to produce tap water.
Which is ridiculous. So
Yeah.
now I want to know, okay, calculations, great.
Yeah.
But real world, I need them to get on it right now and build not just a meter big, but like I need a building, a warehouse size. Let's do it.
Mhm.
Let's just see, does it work?
3 things that they don't mention in the study.
Yeah.
You just got to bring it up.
Okay.
1, where do you get the salt water from?
The ocean?
Well, okay.
Or
So-
from the bog water in your marshes?
Yeah. Part of water treatment, tap water cost, is water treatment plants.
Yep.
That you still need some element of that. But I don't know. I don't know how much microbial whatever's floating around in the water can survive the evaporation trip. I don't know.
This would probably be something that goes along with a water treatment plant. There currently are lots of desal plants that line the coast. Different countries that are more desertified but are coastal. These would come in handy, very handy. The western states are going to be undergoing huge drought issues into the future. It's not going away anytime soon. And so if the coastal regions can be where the oceans are, the salty water can be taken advantage of, that can lead to water sources that can be trucked in places. Not that fixes the problem, but it helps.
The
And
other thing,
the expense is a big deal. Yeah.
is what do you do with all that salt?
That is
at
the
the
big
end.
question. Yeah.
Is it going to be, because if we've separated and say that it is like the water that comes off the microbes don't even like to go up the evaporation things. I don't think you have to look at that. Now you've got this salt brine
Mhm.
that you could turn into salt, I suppose, but you still have.
You'd have to make sure you have the right salts. You have to make sure that it's not toxic salts. You have to make sure that you have to isolate the sodium chloride from other metal salts that might be in there.
Yeah, and then the last final one is, what happens if this catches on and the whole desertified portions of the planet, especially during this climate change and the heat that's coming, we turn it on, we like go after this and use up all of the salt water. Where are the fish going to be? No, that's not going to be.
We're not going to use all the
There's
salt.
plenty.
That's a whole different question. Yeah. But I do think that the effluent from these kinds of desal operations, it's really important to think about that, because right now there are big desal operations that just put the stuff that's left over right back in the water. And so it turns into a really toxic, briny area. And so it can actually be really ecologically damaging. So this is definitely something to consider. Pros, cons. Freshwater is going to be a big issue for agriculture and so much for people moving forward. This is important. This is huge. If it really, really works and scales up, it's huge.
If it scales. If it scales, that is the question.
Mm-hmm. How big does it have to be? How much? Will it still work in the same way? Or as it scales, will there be other factors involved in how it works? I don't know. Anyway, I have a couple stories about our physical cells. We like to think about, ourselves as physical beings, right? You could push against your table and you feel it, but, you could get in a fight, you'd feel that, but, a hug, you feel that. That's nice. But you don't really think about the physicality of the cells in our body themselves, right? Our sensory cells are the things that let us know that we're touching stuff, whether it's a hard surface or a soft surface. But it's not just our sensory cells that are mechanical in nature. There are 2 studies out this week that I thought were really interesting. One studied in Nature Biomedical Engineering that looked at how bodies reject biomedical implants. And very often what happens with biomedical implants is that the implants stress out the body, and there's a scar tissue that ends up forming around the implant. And because the scar tissue forms around the implant, it basically isolates the implant from the rest of the body. And so in a large number of cases, the implant has to be removed because the scar tissue is built up so much that it's not effective anymore for whatever its purpose was. So how do we reduce the scar tissue? Or how do we do we want to reduce the body's reaction to these devices? Anyway, researchers have looked at all this stuff, and it turns out that it's the immune system and an immune response that's responsible for this scar tissue. And people historically have thought that it was due to some kind of chemical interaction. But a group of researchers that put this study together looked at these capsules that were implanted in women who had breast implants. They had 20 patients who had breast implants that were removed, and 10 of them had severe reactions to those breast implants, and 10 who had very mild reactions. By looking at the reactions of the proteins and molecules in the tissue around that implant, they found there's a protein called RAC2, and it's really highly expressed in the patients that had the severe scar tissue reactions. And what that was stimulated by was mechanical stress. Actually, just the implant itself bumping up against other cells. And then immune cells coming into the mix and going, what do we do? But because of the mechanical bumping and jarring, it caused those immune cells that had RAC2 to do big RAC2 signaling and invite more immune cells to come. And because more and more immune cells came to the area, they all started going, we don't like it, and built a fibrous wall. And so you end up with the fibrinogen leading up to the scar tissue around it.
I wonder if there is an attempt first to attack it like it's a cellular thing, like try to kill it.
But it's not
Won't
working.
die.
Yeah, it's still there, and the cells are being bumped.
We don't have a solution. Just wall it off.
Well, normally, if there is a solution, you wouldn't continue for it to happen, right? Mm-hmm. And the immune cells wouldn't need to call more and more immune cells. And so, but it's not just a chemical stimulation that's leading to this immune response. It's actually the physical, mechanical stimuli of bumping into the immune cells that's leading to it. So they went downstream and they found that if they could block the expression of RAC2 in animals, that they could block this scar tissue response and lead to much, much reduced, up to 3-fold reduced production of these fibrinogen tissues. So the question now is, is this something that you could look at to determine if somebody has the genetic profile to have a higher RAC2 response? Do you give them a drug that can block the RAC2 after you've given them an implant? Is that something that would be worthwhile? So is this something that it could actually be conjugated onto an implant itself so that it's not a drug that's necessarily given, but is slowly just part of the implant and slowly leached out and just part of the interactions of the implant with the immune cells around it, which could be pretty interesting. But it's a different kind of way for these researchers. What they say is that it's just a different kind of way to look at implants, not just as, interacting chemically with the body, but actually the mechanical stimulation that occurs and how that impacts the cells themselves as well.
Yeah, this is also what happens when surgeons leave sponges behind.
Yeah. Yes.
They get walled off. They get surrounded. They can look like a tumor later, and then they do biopsy, and they will find, oops, you had surgery in this area, yeah, yeah, okay, yeah,
okay. And the second study that I thought was really interesting, again, it deals with the immune system, but this time they were looking at how immune cells bind to antigens. So normally an immune cell, a B cell, has a receptor on it that is like looking for weird things, weird little bits of protein that cells are holding out, going, this isn't supposed to be here. And so when that B receptor cell goes and bumps into the antigen, it's like, ooh, okay, I'm gonna grab onto that. Oh, we don't like that. Okay, now we're gonna make an immune response. We're gonna eat this cell. Okay, that's done. But how does that happen? And we think of it, again, as usually occurring on a very chemical level. But it turns out that there are mechanosensitive ion channels. Cation channel, which is a positive ion channel, usually like sodium or potassium, that gets stimulated by physical mechanical deformation of the membrane of the cell. And so in this study that they just published in Science Signaling, they discovered that B cells are really strongly stimulated when this particular mechanosensitive channel called piezo-1 gets stimulated. And it needs to be mechanically stimulated for the B cells to respond to antigens that have been presented by the membrane. So if there's a cell waving an antigen out, it's like the immune cell has to bump into the other cell and do the handshake, and that handshake needs to be a firm one that really shakes the immune cell. And when it shakes the immune cell, it gets that mechanosensitive ion channel to open up, and then the immune cell, the B cell, goes, oh, okay, now we eat you. You're not good. We eat you.
We eat you, or we call somebody to eat you.
Or we call someone to eat you, yes. And so this, in this study, it's in itself, it seems kind of small, but what it potentially means is that as we look at how to design vaccines for the future, it's how can we create vaccines that work really, really well when they're membrane bound to be able to stimulate these mechanosensors to be able to really activate the potential of a vaccine in the body.
Or prevent it from happening.
Or prevent it from happening.
So
that too.
One of the interesting things in the COVID severity cases has been recruitment of killer T cells or lysing T cells, CD4s, probably likely by the B cells. But it's the virus actually attacks the B cell, so that the B cell, which normally has kind of a doorman, saying, "Oh, there's too many lysing the T cells around here. Rest of you go home. We're not letting anybody else in tonight if you're a T cell." That gets broken down by the virus, which then it just keeps recruiting. And so a lot of the damage from the severe cases of COVID were because of this B cell signaling pathway.
The immune system.
Allowing more damage to be caused to cells than needed to be to clear virus or attack. It wasn't even attacking virus. It was attacking cells that may have had the B cell attacked.
Yeah, so there's the complement immune system, which slides in line with like the I forget all the particular terms for the different names of the immune system, but there's like the immune system that's our skin, that's the way that we move and like sweat and that kind of stuff. But then there's the B cells and T cells, and that's another part. And then there's the complement system, and the complement system is really part of the confusion and a lot of time those signaling cascades that lead to inflammation problems and real severe disease. It's a mismatch between one system and the other.
Is it innate? Is it the innate?
The innate.
Yeah.
There's experience, and there's the one through experience. But yeah, the B cells and T cells, those are like your experience. There's the innate, which is your skin and your sweat and that kind of stuff. And then there's the complement system, which is its own bucket of worms. So much fun stuff when you get into the immune system. But I think this adds like another interesting level to, how cells interact with each other. We forget that down at that cellular level, it's a bunch of bumping and jostling and moving around. And that in itself is important to the ecology of those cells and how everything is maintained biologically.
And that is also a thing that is missing. Like when you are trying to chemically formulate and genetically formulate and create a picture of what is taking place and then have a drug target with a chemical reaction, if you've missed the fact that once you get there, you got to shake hands really hard with the other cell,
We didn't do
your
that.
entire thing that works on paper, that chemically should all interact, isn't doing its job.
Exactly, because you missed that physical.
Because you missed a physical mechanical interaction. Oh my goodness. Yeah, I could see the people staying up late at night, sleeplessly, their hair turning gray. You could watch it turn gray because everything should work and it doesn't.
Is it not
Because
working?
the body is very complicated. And
Because
it's a real thing.
biology
It's
is
not a thing on
mushy.
paper.
Oh, biology and our listeners. Everyone, I am so glad that you're here with us for This Week in Science this week. Thank you so much for joining us and taking this time with us during your week. We're so glad that you're here. If you are really enjoying the show, make sure you head over to TWIS.org. Click on the, Patreon link. Oh, yes, Patreon. That is how we bring everyone together to support the show. If you're interested in helping support the show in an ongoing fashion, become part of the Patreon community. Join there and support us for as much as you can per month, $10 and more a month, and we will thank you by name at the end of the show, $15 and more per month, and you'll get some stickers. It's pretty awesome. There's other things as well. Additionally, you can click on our Zillow link and head over to Zillow, get some really awesome TWIS goodies. We've got shirts and hats and stickers and other things for sale over there. And if none of this works for you, just, tell a friend about TWIS this week. Make sure you get a friend to subscribe to TWIS. Do that this week. That would be a huge help. All right, coming on back to the show. Still no Blair. But Justin, you're just in time to tell us about the science you brought.
So this is the thing we've talked about in a few different contexts on the show, which is wooden artifacts rarely surviving from ancient times. Well, we have so much evidence of the past through stone tools and the occasional fossils. We have very limited information about when and how hominins were using a more kind of basic raw material in wood, because it doesn't survive. It doesn't survive the test of time. It's too organic. It breaks down too easily. Now, new earliest evidence for structural use of wood in the archaeological record has been discovered in waterlogged deposits at the archaeological site Kalambo Falls in Zambia. This is dated by luminescence dating to at least 476,000 years ago.
Whoa.
Take another 23,000 either way. So
right.
450 to 500,000 years old. They have found preserved two interlocking logs joined transversely by an intentionally cut notch. Now, that might not sound like the most exciting thing in the world, but it is.
Mm-hmm.
So one of the logs is over 4 feet long. What's left of it there, and the authors are suggesting it could have been used as the base of a structure. It kind of looks like if you are a certain age, it kind of looks like the notching of a crude Lincoln log, or the like a log cabin, where you notch out the ends somewhere near the ends of the wood, and then you stack them on top of each other, and then they're kind of linked and they hold their place. So it very much looks like the oldest log cabin ever built. Expert analysis of stone tool cut marks on the wood showed that these early humans, shaped and joined two large logs to make a structure. So the age, 450 to 500,000 years ago. This predates what current modern humans call modern humans.
We're only supposed to be 200,000 years old.
I think we've pushed it back a little bit more, but not by much.
But seriously,
yeah.
What?
Yeah.
What?
So this is highlighting something that archaeology has also been hinting at for years. There are places on this earth where we have found the remains of Neanderthals, Homo erectus, islands far out to sea where, regardless of climate, there was never an opportunity to walk to. We have Crete and Aegean, Philippines and Indonesian islands have records of Homo erectus. These are places where a swimmer with Olympic modern human swimmer abilities would find challenging to reach, let alone a pod of early humans that didn't have a practice pool. So it has been suggested that boats, some form of crude wooden flotation device, may have been needed to traverse these scenarios, but we don't have any records of it because wood doesn't survive time. And there's no evidence of woodworking and wooden structures that old.
No.
Until now.
Because wood would break down unless it's fossilized or,
Yeah, the conditions in which, bone will fossilize are better than you will get a preserved wood. And even if they're side by side, the wood will degrade. And of course, the stone tools that were used to work this, we have seen. And it may be that there's other stone tools, stone axes, that we have thought of as meat rendering or, crushing of nuts or something, that have been woodworking tools all along. We just don't know because we haven't found any evidence to suggest that they were doing woodworking this far back.
Because
now we have
right
something
conditions for making that happen hadn't occurred until this finding, potentially.
Yeah. This is a buried, waterlogged find. 476-ish thousand years ago. This is in Africa. So this isn't Neanderthal. Maybe a little bit older than this isn't a Neanderthal. So a Neanderthal should already be out and proto-Neanderthaling. Somewhere in the Caucasus or Europe. They should be heading that way, at least out in the Levant. This isn't likely early current modern human. At least it would have to be pushing that back a lot further. So right now we don't know.
But
one of the
the timing would suggest what? This is South Africa, so this is going to be.
Is it? Or Zambia?
In Central Africa. I'm sorry. Central Africa. Yes.
So our earliest,
still.
Part of the problem too with Africa is that
could be anybody.
Well, it could be anybody, but it's also, it doesn't have the places where you're most likely to find preserved skull fossilization for that process to be slow enough tends to be very cold environments. So Africa, for as much early history as we've gotten out of Africa, it's actually a terrible place for fossils. It's just so big that we found a lot. But in terms of conditions for preservation, it's terrible. Is it possible that early humans, modern humans, go back further? Yes. Is it possible that other humans that we have not yet even fully understood to have existed have created this? Yes. Is it possible that one of the humans that we have found some evidence of, but don't have a good timeline for how long or over what territories that they live. Like whatever the thing is that they've been finding in Morocco, like whatever that is, which is looks kind of like a Neanderthal and kind of like a current modern human, but it's too old to be either. And it's like, what? There's all sorts of mysteries yet to be. But again, terrible fossilized record. But this showing woodworking, I think, is pretty amazing. This is the oldest actual structure made by humans of wood ever found on the planet.
And I think what the evidence that they've looked at to make this seem like it was built, that it was structurally modified by humans, are the repeated scratch marks that exist in particular directions that don't make sense. So if you just put two pieces of wood together and they rubbed each other over time, they wouldn't make the same kinds of scratch marks that they've seen on this fossil. Yeah.
Oh, and they've also, within that dig site, they have found the tools. The tools are also there. So it's not just the wood isolated from, but there are also...
this was their shipbuilding factory?
Yeah, kind of. Yeah, I mean, it doesn't look like I don't know, maybe it's for the river, but I don't know if this thing floated. It looks to me like the beginnings of a shelter, like a log cabin. But there's different. They also found different carved stick configurations. One they called a digging stick, and they don't know what it was for. It might have been a stabby stick. You have no idea. But or children's toy. For throwing rocks up in the air and hitting them with the stick. You don't know. You weren't there. But there's all kinds of other evidence in the area of some messing around with wood and having all the tools to do it. Which was what the site was looking at to begin with, and then this got discovered, and now they're like, oh boy. One of the things they mentioned in the study is this might change the view of nomadic early hominins, but it doesn't really.
But it doesn't. They were nomadic.
Because nomadic doesn't mean just wandering blindly across. It usually means you might have like a seasonal home. You might have a winter home, you might have a summer home, but you go back to the same locations usually seasonally. So this place may not have been lived, even nomadics may not have lived in one location year round. They likely lived in that location just about every year.
Generally.
For maybe thousands of years. Like, nomadic is very... We're just stationary today. That's the thing. That's what's different.
What do? I'm a nomad to my kitchen and then to bed.
I wander around them times in seasons of the day.
Maybe I go to the grocery store. Yeah, I think this is an incredible find. I think this is the kind of discovery that we've been waiting for, that is the kind of thing that takes the data that we've been looking at and going timelines of hominin, of homo, whatever species. They don't make sense, but we don't have all the fossils yet. We need more bits and pieces. And this is one of those pieces of evidence that'll fit nicely into the tapestry.
It's so wild to me, like how many new hominins. Like there was already plenty of hominins in the past. And then since we've been doing this show, I think there's been like 4 or 5 more added. That's just wild. How many hominins, how busy they were, getting into all sorts of things. My final story of the evening.
Oh, yes.
Is also something I worked up for Medical Express. It's out there somewheres in the world. Safety concerns about youth access to online marijuana dispensaries. This is researchers from the Stephen and Alexandra Cohen Children's Medical Center of New York. They published in JAMA Pediatrics. And they basically did a data collection from 80 websites that are marijuana dispensary websites, 32 different states. And they were kind of focused on things like the shipment regions that they would send to, product types, age restrictions, and verification, delivery and pickup options, warnings, disclaimers, payment methods, this sort of thing. In relation to underage access to dispensaries. So
Which
upon arriving
there shouldn't be, right? Underage access to dispensaries?
No, of course not.
No. Yeah.
Upon arriving at a dispensary website, 56 or 7 of the 80, 70% prompted users to either click to have to, like, are you 18 came up on the screen, and then they had to click.
How that works.
Yes, if they are, or no, if they aren't, and then don't get access to the website. It's unclear because they weren't studying how effective the actual button click screen was. My guess is not very, in terms of deterrence. 3 websites asked for specific birth date. We were talking about scams earlier. Never give your real birth date to a website just to see the website.
No,
Ever.
you don't give your real birth date anyway. I mean, don't give your real birth date. You don't do that.
Right. So what's the point of asking somebody's real birth date if nobody's going to give their real birth date?
Nobody's going to do that.
Nobody's going to do that. I bet you if you looked at the other side of that data.
No, but if we caught you lying, gee willikers.
I bet you if you looked at the other side of that data, this is all just disclaimers for, lack of liability thing. Well, they clicked the button, so they lied, not us. We didn't get it. But I bet you if you look through the other side of the data, they will probably have a lot of those people who are filling that out who were born on April 20th. None of the sites required verified age documentation to enter the website, which that would be weird if you had to show your ID to your computer in order just to see a website. And my goodness, websites would get spoofed and spam. This would be the epicenter of every scam phishing expedition from here on out, right? That would be terrible if that became common. Age verification was required when completing a purchase or upon receiving a marijuana product from 53 dispensaries. So 66% required some form of age verification to actually receive the marijuana product. 15 or 18.8% did not require any formal age verification during the purchasing process. And if you're underage and listening, no, I don't know what sites those were, sorry. Age verification methods included government-issued identification at 40 of the dispensaries. Medical marijuana identification number was needed at 21. Self-reported birth date was sufficient at 8. 53 dispensaries offered a pickup option, and many offered delivery. 67% also offered delivery. Half of the dispensaries provided legal information, disclaimers, while many didn't. And 27% offered delivery across state lines from the dispensary's location, which is sort of interesting because that could be sent to a state where it's not legal or differently legal.
Depends, yeah.
Anyhow. So now we know this is all these different. There's not a uniform way that an online dispensary operates in today's environment. Okay. So 1 in 5 dispensaries required no formal age verification at all at any stage during the
20%
process.
Yeah.
The authors conclude it is imperative to require strict age verification procedures prior to cannabis purchases online and to establish stringent surveillance of online marijuana dispensaries to protect youth. That's where that story concludes. The study concludes.
And this is where we're going to go into the what did you take home from this that surprised you?
Well, the question is, how would it protect the youth?
How do we protect the youth?
How does it protect the youth? Because the thing that, providing marijuana in this sort of structured way where where it's regulated, where there's a measure of safety in the interaction, purchase interaction, where it's not coming from a black market. And there's a level of safety, especially since the United States has a fentanyl lacing crisis where people are dying of overdose from taking the thing that they didn't know was in there. How is this protecting children if adults are all saying, yeah, we love the new system of legally being able to get marijuana without having to deal with criminals or funding the black market? Why would it then be okay to send the youth to the black market? Why would you want them in the black market? I'm not saying it shouldn't be legal. It shouldn't be like intentionally authorized. But if we just
No.
the loopholes that are there might be okay. And here's sort of how I come to this conclusion, because currently there are, what is this? This is according to the Monitoring the Future National Survey results on drug use, which is a CDC cited report, which is one of the main go-tos for the National Institute of Health to point to when they're talking about statistics of drug use. The prevalence of marijuana use in 2022 amongst high school seniors, 38.3%.
Okay.
Have at least tried it once, and many, I think it's like 6% of them are daily users. 38.3% though have tried it. So you're saying you would take 38.3% of seniors and send them intentionally to the black market to go procure the marijuana. Now you might say, but 38.3%, that's a problem. That's a high number. Actually, it's not. It was much higher in the past.
When it was more illicit, right?
Huh?
When it was more illicit. When it
was illegal. So check this out.
Illegal.
2012. Yeah. Senior age marijuana use, 12th grade marijuana use was reported at 45.2%. 47.8% in 2002. It went all the way down, though, surprisingly, 32.6% in 1992.
I wonder what.
But as I recall, we had other drugs. 1982. Oh, back those kids of the 80s, they weren't doing the marijuana. 58.7%.
Wow.
The class of 1979 had the highest reported marijuana. These are people who are now
running the country.
60-year-old fuddy-duddies, right? Like, oh, the kids today. Hey, got a problem with the kids today. Hey, they're too lazy. They don't work hard enough, right? Class of 1979 had the highest reported marijuana use at 60.4% of students.
That's
according
wild.
to the national survey that's been going on this whole time. Okay.
It also wasn't as strong back then. So.
Yes, it was. Yeah, actually, no. So another thing that's in this survey, which is really interesting, because you always hear that, but they actually survey for duration and intensity, and it looks like duration and intensity has been the same the entire time.
Interesting.
Yeah. I think they may have needed to smoke a little bit more to get there back then.
Right. Yeah, exactly. Yeah, exactly.
They were, you know, that's why they're...
It wasn't as bred to be as strong, each strain.
Yeah. But that just meant you got, you know, a duffel bag of it instead of a fanny pack. Anyway, we're not talking about that.
Yeah. No, we're talking about
access to marijuana.
And access, yes.
Access to marijuana over the history of prohibition. It's clearly not been an obstacle for the American youth in acquiring marijuana. Yeah. And now that the adults are all happy, who were these kids, by the way? The adults who are voting for and utilizing dispensaries were these kids. Mm-hmm. Now that there is a safer, legal, taxable system, you would, I'm just saying maybe not close all the loopholes. Here's an interesting statistic too. California alone.
Or figure out how to do the loopholes better. So, like, for a moment here, instead of just having a website where you have to click a button that says I'm 18 or give a birth date, how about if you're going to be getting from a particular dispensary, you have to actually have a relationship with that dispensary where they have your information on file so they know exactly. They've seen your ID. You've turned in an ID. They know,
No.
And
that gets rid of the loophole. You got to keep the loophole.
Oh, wait, but this is for kids. This is for adults. Yeah. I mean, and so then if it's kids, they won't be able to get it because it'll have to be an adult.
Yes, and so they're going to have to go down to the drug dealers who aren't specializing in marijuana anymore because, they're all the dispensaries. They're selling harder drugs laced with fentanyl, and then the kids are dying. So, forget it. Keep the loopholes.
This is a slippery slope argument. Just
wink, wink, nudge, nudge. Mm-hmm. Allow the liability disclaimers. Here's the thing. Also, they kind of point out, like, one of the things that they recommend is, like, there's too many anonymous ways to pay. Mm-hmm. And that would be one of the ways that you could kind of control youth access. The problem is that wasn't created by the dispensaries. That's the whole federal banking law unclarity thing where, like, major banks wouldn't take deposits or do transactions for the dispensaries. So that whole anonymous industry is the fault of law.
Banking and
it has nothing to do with the dispensaries choosing that path.
Yeah.
But I don't know. It looks like the American youth have been made up their mind a long time ago.
And they're figuring it out. I mean, I don't know. We can protect the youth as much as we can by talking with them honestly about things and being honest about the fact that, hey, if you start smoking weed before you're an adult, or if you start drinking before you're an adult, it is going to impact your brain in a, not so beneficial way. That, yes, you're going to survive, but your brain isn't done maturing until your mid-20s. And you start getting into this stuff in your teens, and it leads to lifelong patterns.
I know people who are lifelong marijuana smokers who have had entirely pretty successful. I mean, there's a few. Oh, yeah. I kind of see your point. Really kind of adding up who's who. That actually makes some sense.
I'm going to add up a little bit. Yeah, I don't know. I think this is a very interesting question, though. Yeah, what do we do to protect people? But how do we protect people from themselves? It's hard to do.
Well, the other thing was I was sort of wanted to answer. I didn't realize how much. There's $4.6 billion since legalization started that the state of California has collected in the taxes, which is a fraction of the price.
Yeah.
Oh my goodness.
Yeah.
I should have been doing illegal drug selling all those years. It's a multi-billion-dollar industry for marijuana. Who would have known? And the only way it could have been that is if it was already like accepted by the population.
Yeah.
But the fact that just the taxes over those like 5 years or whatever it's been is like $5 billion, and then it's the price of the thing on top of it. Like, that was a huge industry that the criminals must be really upset.
I know. That's why they've moved into different areas. Oh, boy. Well, let's talk about the brains of all these criminals and their emotions. They must be feeling, being upset, all that money that they used to be making.
Oh.
Better have my money. Beep. Better have my money. So where do our emotions come from? You feel things, right? And emotions build up to lead to your overall mood. Otherwise, mood can also influence how you feel a certain emotion. So if you're overall happy, feeling good, I'm in a pleasant mood. Okay, you're more likely to respond positively to things as opposed to negatively. So your emotions may stay more positive. Unless, of course, you're like in a bad mood, and then you're going to respond in a more angry or upset way to somebody, potentially, as opposed to in a more positive or neutral manner. Where do all these things come from? They all come from biological need to survive. These are all behavioral strategies that animals have had, building on them over eons of evolution. So what are the mechanisms that have evolved over time to lead to what we now consider emotions? And the difference of a human having an emotion and something like AI that can only, Patrick, machine learning that can only simulate an emotion. Well, these researchers just published their work. They're out of Nagoya City University. They just published their work in genetics, and instead of working with mice and rats and other more related mammalian species, they went down to the worms, and they decided to work with C. elegans because it's very well known in the lab sector. Its genes are very well understood. We've sequenced its genome, and we're able to impact it very significantly in the laboratory.
And its emotional range is just much broader than you would expect.
You would not expect them. Yes, exactly. And so the question is, okay, emotions in a worm, how does this connect? Well, they're not really looking at the emotions, but they're looking at the behavioral repertoire of these worms. And they found that, these worms, they really like their food that they eat. And so they eat these little bacteria, and the little bacteria they follow those bacteria. They love those bacteria. Those bacteria are very important to their survival. They're going to do just about anything to hang out with those bacteria and be where those bacteria are. However, when they applied an electrical stimulus to the worms went wiggle, 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 wiggle. And they tried to wiggle their little wormy way away from that electrical stimulus as fast as they could. And in fact, some of those worms, they kept wiggling and wiggling and wiggling way longer than really should be recommended for a normal worm who's trying to get away from an electrical stimulus. And so the researchers said, what's the difference between these worms that keep running and running or wiggling and wiggling and wiggling, and these worms that they wiggle for a while and then they stop and then they go back to their looking for food? First, the fact that these worms don't just wiggle a little bit as soon as the electrical stimulus is over and then go, oh, the stimulus is over, I'm done. They don't do that. They keep wiggling a bit longer than you would expect. It's usually like, okay, we stimulate you with electricity. That's danger. You wiggle to get away from it. Stimulus goes away. You stop wiggling because the stimulus is gone. But these worms, they're like, I'm going to keep wiggling. I'm still wiggling. And then, like I said, the other ones kept wiggling, wiggling, and wiggling. So what this suggests is there is a pathway that's inherent in the brain, the nervous system of these worms, that leads the worms to preferentially not go after their food, to escape from danger, and to continue escaping from danger until they're really sure that they're away from it. And they say that this could be attributed to an early mechanism that might lead to emotions, because it could stimulate some areas and using similar chemicals, neurotransmitters, neuropeptides, very similar to our hormones, that would leverage these advantages of these worms. So they found that these worms, basically, they were able to isolate these neuropeptides. They were able to find genetic mechanisms that underlie the production of these peptides. They were able to change the levels of the peptides in different worms. So they were able to create worms that ran longer than you should, and worms that would not run long enough. And in doing this, what they think is that if they can kind of balance this idea, like a basic idea with like depression or emotional dysregulation, that those worms that run too long, that maybe they don't have the neuropeptides that tell them to stop at the normal time. And so the signals that get turned on for fear or anxiety or being upset, sadness, that those signals don't get turned off. And that maybe this mechanism is something that is very basic to biology.
Well, isn't that what the amygdala does?
Right. Yes. Yeah. But is it like the mechanism? Yes, it's a stimulus response. But what is happening in there? What is it that's, the basic mechanism? Like this is going into like deep into like not just the emotion, but the neural chemical signals that are occurring at a very basic level. And are there preserved genetic components that are there for a reason, for survival? And that if we understand what those preserved genetic components are, that maybe those genetic components could become targets for treatment.
Yeah, so you'd get an injection into your amygdala that is like, okay, we can turn off these signals now.
Yeah, turn it off.
Because the amygdala, that's the problem with the amygdala. This is why the amygdala is such an issue at the core of so many different things. Is problematic. Is that it has a hard time receiving signals. It can send them, but it doesn't take back the information very well. Because it's primitive brain part. I'm speaking part. In like primitive monkey brain, or maybe worm brain now. I don't know. It sends out all those distress signals, but the thinky part of the brain that goes like, that was alarming, but I'm watching a movie right now. I don't actually need to run. Thank you for the fear response, but I am good now. And then
Thank you very much.
If you have a problematic amygdala, it keeps telling you to run, even after you've left the movie theater. Even if you're home. Now you're home in bed at night trying to sleep. And because the fear response was triggered during the movie, your amygdala is still telling you, hey, get up and run. You're like, I need to sleep. This is already in the past. But telling the amygdala that it's okay to chill out is very difficult.
Chill out, amygdala.
Apparently, it's like the basis behind like most PST or PTSD.
PTSD, yep.
Yeah.
Overactivity.
Amygdala centric. The amygdala continuing to fire danger, danger, danger long after, and just not receiving the cease and desist orders from the main conscious-y, thinky brain.
Yeah, so the worms don't necessarily have a main conscious-y, thinky brain, but they do have neural networks. They have these, these ganglia of nerves that act to allow basic responses. But these basic responses are also mediated by these neuropeptides that either accentuate or negatively impact survival. And that's where we came from, everyone. Worms. No, we didn't come from worms.
There was a fish story that I didn't bring. Did you see the fish skull story?
I didn't see the fish skull story.
They think they found the first skull.
Ooh, the very first one?
Yeah, like like the very first one, like
the only one,
like
the first one. That was it. This is the first one we made.
So, it was like a fish with like a collagen wrapped head, where the brain was becoming separately protected from the rest of the body. I didn't bring it because I saw it only the last second. Didn't have time.
There's never enough time for all the things that we want to be looking at. Never enough. So the next study has to do not with the amygdala, but with the brain and our response to loss. So what does the brain do when we lose things, whether it's people or stimulation or a job? You grieve, right? We have a loss reaction, and we adapt to loss. But in some cases, loss can be maladaptive. We experience loss, and that can impact us very negatively. And why does that happen? So this research, which I'm not exactly sure really gets at loss, but I mean, I am not a rodent, so this is not something necessarily. Anyway, these researchers had mice in an enriched situation. So they had a bunch of mice and they gave them a wondrous world to live in. Lots of things to play with, all sorts of stuff to do, other mice to hang out with. It was like Mouse Disneyland.
Nice.
But, yeah, they had a great time. And then they took it away. Made the mice live by themselves in sterile, empty boxes.
No.
Yes.
You can't do that.
They did that. They did that to these mice. And so, this is making
equivalent to going to Disneyland.
The losing,
having to go home.
And having to go home, taken away from all that stimulation.
Your sterile box. In your sterile town with no rides or costume characters.
Go back to your house.
Things aren't as magical.
Okay, so they took them away, and they had a 2-week period where the enrichment was removed, and then they looked at the brains of these rodents, and they found that there were some significant changes in different areas of the brain. So these rodents, it seemed as though the brain became less plastic, and there were particular areas that were more affected than others. But overall, what they saw is the molecular response was to downregulate a whole bunch of molecular commands that normally lead to plasticity of the brain, connecting, making new connections. It's as if the brain kind of stopped. And then they saw that there was a change kind of in the insulation of the brain. So all of the cells that normally support the brain and the extracellular matrix, which actually physically supports the neurons in the brain, those became more insulating, as if they were putting armor around the neurons and holding them in place. So I think it's a really fascinating result that they found here, where looking at the genomics, the proteomics, the various aspects of what was happening, and also in the physical changes to the brains after the enrichment was taken away, it led to significant changes that could be equivalent to loss. But then the question is, is it just that all the enrichment was taken away? And is that just what happens when you take away enrichment? I mean, and in a sense, that's not just what loss is, but I don't know. I'm still struggling with this one a little bit. But I also think it's really interesting that the discovery that the support cells, so the microglia, became smaller. They became less phagocytic, so they were breaking down fewer cells that needed to be broken down. They weren't doing the work that they needed to be doing of cleaning up the brain. It's kind of interesting. I don't know. Do you think it's an equivalent to loss? Taking Disneyland away from mice? I don't know.
Well, what is it locking in, though? Is interesting, because you know what it almost reminded me of? The study of students who drink versus don't drink after
and
after
when they're
class,
studying,
and how well that they do on an exam on that information. Like, it almost seems like locking in information after a lack of stimulation.
Mm-hmm.
Where you're not competing against it anymore, and so maybe you're that's the important thing, is the thing that was that stimulating event,
right?
When
don't lose it.
Yeah.
Don't lose
Hang
that.
on to the magic.
Hang on to it.
Yeah. So I mean, whether it's loss or this is maybe just kind of looks more like learning to me.
But it's like we were learning, the brain was changing, it was plastic and everything was really exciting, but now, it's all taken away. So stop.
Yeah.
No more changing.
Right. Stop. And let's lock in what we have learned.
Yeah.
That's how I kind of read it. That's the sense I'm getting of it, as opposed to, yes, why are we not being more plastic and changing things right now? Because there's no more input that we're interested in. There's no more
Which makes
stimuli
sense.
to learn
Which
from.
makes sense from like a lack of enrichment. It's like, okay, all the stuff, but if you lose, like, and you're experiencing grief because you've lost a person, I mean, you're still in a world with all sorts of enrichment, and there's all sorts of stuff going on, and there's still the potential to learn, and there's still stimuli. So I don't know. I think I'm just having issues with what they're trying to get at with rodents, which is a very complex human interaction.
It just doesn't. I mean, there could be a lack of interest in the current sterile environment.
Yeah.
But like that was the whole thing with studying and drinking. Is the students who actually drank at night tended to do better on the exam the next day, and the idea behind it was they stopped adding memories while they were drinking. Their brain shut down. So the only thing the brain had to lock in that sterile environment of the drunken brain was the information that they'd learned in class. Whereas the non-drinking students went out, they saw a movie, they talked with their friends, they watched some other thing, they looked something up on the internet, they had competing plasticity and enrichments that didn't lock in the study as well.
Yeah. So
what this looks like when you're showing this lack of enrichment period post a high enrichment period just looks like the process of committing things to memory, to locking those things in better, and that there's nothing else to work in. So don't let it go. Don't clean up the trash because we got nothing to replace it with.
Nothing yet. We might need it later. Yeah, but I think it's really interesting that a lot of this response was immune and support structure for neurons and not the neurons themselves. So, I mean, there were neuronal changes, but a lot of it was like the immune system, the microglia and the supports, the extracellular matrix.
Now I want to see a version of this.
Yeah.
It has to be on humans, which is going to be tricky. Or maybe you can figure out how to get. So what we would need a rat to go up in front of a classroom of rats and teach something very excitedly about, there's cheese. You got to find this way to get cheese. And then another rat to come up in a different group that's like, and to get the cheese, you must approach the trap from the correct angle.
How do you teach? How's the teaching?
How do you teach boring? I have the unenthusiastic learning environment and the enthusiastic learning environment, and do the same thing, and then take it away and see which one gets learned better. Maybe that's the problem of the unenthusiastic teacher from the earlier story we were talking about, is that they haven't created that enrichment environment in the first place. They're trying to teach to the sterile room where that's not where you add information. That's where you lock in the thing that came before it.
Exactly. Well, it turns out my last study is a study in current biology. This last week, researchers looked at babies. First time in the lab at the age of 6 months, final visit into 18 months old. And the researchers looked at interactions between mother and child and imitations of the mother and the child. And so the question was, when do kids start imitating? And why do they start imitating others? And from this study, they have concluded that babies imitate people because people imitate babies. They found that mothers who were more sensitive to the reactions of their kids were more likely to interact with them and to copy what their babies were doing. So if the baby did something, the mother would be like, woo, loo, and imitate what they did. And those babies were more likely to begin imitating their mother earlier and to continue the imitating behavior with other individuals. And so they think, this is not just for mothers, but interactions between parents and children create the situation that leads to imitation. Imitation leads to learning. And so there's this very basic feedback loop that we think is just in the brain. It's like, oh, babies, they imitate. No, people imitate, and then babies learn to imitate, which I think is fantastic.
Yeah, imitation is a really rare form of intelligence. I mean, it occurs in the animal kingdom, but not a lot of the animal kingdom.
Right. So if you think
see
of
a behavior and imitate it.
Yeah, a lot of primates can imitate, but how many of them during raising their offspring, the way that humans dote on their babies, how many of them are making imitative faces, are doing imitative behaviors? How long ago did humans begin this imitation behavior? And is that one of the things that sets us apart a little bit? It also makes me wonder about child development and, parents who are, or children who are raised in environments with parents or even just individuals who are less responsive, where they don't have that input for imitation. What does that mean to how the child develops and how they learn to learn moving down the line? And not just how they learn to learn, but how they learn to interact socially. Because a lot of the social cues we have are based on the subtle art of imitation. You make other people comfortable by imitating body language and leaning in a similar way, or leaning back to make, there are certain things that we learn to do. And if you're not being taught to do that from a very, very early age.
We're talking to you, close talkers.
Yeah. And is there a sensitive period? Is there a period of time during which it's a really essential period of time that children get this imitation behavior? Is that important? And so this is I think a very, really interesting and important study for just our understanding of child development, social learning, and then human behavior moving forward. I think it's also evolution. Did we start imitating? Is that something that really led us on? I don't know. To be human?
Yeah, it feels like this is probably a very ancient human-y thing. We've had even more expressive brows in the past than we have now. I don't know if they could do this. I don't know if you could raise your eyebrows when you hit a brow ridge.
That would be difficult. Raise the whole ridge.
Neanderthals could actually raise an eyebrow on both of their... Maybe they just look surprised all the time. I don't know.
Or brooding. Probably more brooding. But
yeah, it's interesting. It's very interesting. Who's imitating who? Because they definitely do pick up characteristics, but they definitely have their own personalities.
For sure.
Too. As a parent, I can totally picture myself just following their lead. Without meaning to, intending to, or thinking about it. It just... Okay, that's how you were talking, so I will speak your language. And
that's where baby talk comes from, right? You're imitating the baby. Okay, I'll talk to you like you. Okay, that's great. We're going to do this like you. It's all, yes. Anyway, people imitating babies leads to babies imitating people, and so on and so forth through the end of time. Have we made it to the end of the show?
I think we might have.
I think we did it. Everyone out there, don't forget to send us your stupid questions this week. I'd love to get your stupid questions. Don't be afraid to send them. There are lots of places you can
I'm afraid
to
read them.
I know. I can't wait. It'll be kind of fun. I cannot wait. Anyway, hey everyone. Thanks for listening. Thanks for being here tonight. Thanks for being in our chat rooms. Thank you for being in the Discord. Thank you for watching live, if you're watching live right now. Shout outs to Fada. Thank you for your help with social media and show descriptions and show notes. Gord and Arnlore, thank you for helping in the chat rooms, making every place happy and wonderful to be. Identity 4, thank you for recording. I'm sorry if my levels were off. Rachel, thank you for editing the show. You get to deal with the levels being off, so sorry about that. And everyone, again, who's here right now, thank you for being in the chat room. And of course, as always, I have to thank our Patreon sponsors who keep this show going.
By the way, last week, I think took me 20 minutes.
You have to read.
This is hard. You do such a good job at this. I've always taken for granted how easy it is to read 5 pages of names. And yet it took me forever, and I stumbled over names that I've heard a million times. I just can't say it. And
I do have like a little internal thing where it's like I get really excited if I get to the end of the list without stumbling once. It's very rare, but it's I have a little celebration.
Well, no pressure, because we're all paying extra close attention this time.
Thank you, TWIS patrons. Thank you to Arthur Kepler, Craig Potts, Mary Gertz, Teresa Smith, Richard Badge, Bob Coles, Kent Northcote, Rick Loveman, George Corris, Pierre Velazarb, John Ratnaswamy, Carl Kornfeld, Chris Wozniak, Vegard Shefstad, Donathan Stiles, a.k.a. Don Stylo, Ali Coffin, Reagan, Shoe Bruce, Sarah Forfar, Don Mundus, P.I.G., Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Fredus 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard Brendan Minish, Johnny Gridley, Clemmy Day, G. Burton Lattimore, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Ronnie Lewis, Paul, Rick Ramus, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Adam Mishkan, Evan Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul D. Disney, David Simmerly, Patrick Pecoraro, and Tony Steele.
Woo! Well, thank you to all the Patreons, and amazing job, Kiki. First time back after a couple of weeks. Got through the whole list. Nailed it.
There we go. Thank you, everyone, for your support on Patreon. And yes, we do want to make this list longer if we can. Make it tough on me. Become a Patreon supporter. If you are interested in supporting us, you can find information by clicking the Patreon link at twis.org. And on next week's show,
we will be back broadcasting 8 p.m. Pacific time on a Wednesday, or Thursdays, 5 a.m. Central European time, from YouTube, Facebook, where else? Online at twis.org/live.
You're like, all the places, where do we go?
We are all the places where the show is broadcast.
Yes. If you'd like to listen to us as a podcast, look for This Week in Science. All the places podcasts are found. How does that sound? If you enjoyed the show, get your friends to subscribe too.
For more information on anything you've heard here today, show notes and links to these stories, which will be either the studies or links to the stories with the study linked in them, will be available on our website, www.twis.org. And you can also sign up for our newsletter.
It's such an exciting newsletter. You can contact us directly. Email Kirsten at kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twist.org. Just put twist in the subject line so your email doesn't get spam filtered into the neuropeptides of that worm who's wiggling away from the electric shock. Never gonna get
Oh my goodness. You can also hit us up on the platform formerly known as Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. And I'm starting to do a thing I'm going to stop doing pretty soon. It's Sci-X Files, where I've been putting the stories that I wrote for the other science-y outfit I've been putting there. But I probably won't be doing that one too much longer. We'll see.
We will see. And we will be back here again next week. We hope that you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.